It's like an old red and wooden wagon. So I don't think I really was very clear about how to do number 1 and 2 Fridays. So I want to get your attention with it right off the bat here. I did a few at the end of class, but what this is actually called is change of base formula. So you do have a test this Thursday. Chapter 7. Yep. So for numbers 1 and 2, if you don't know log 11, you don't know 9, you can rewrite this. So it's log 11 of 9 can be rewritten log 9 divided by log 11. And the reason it's called change of base formula is that when you do that, these both now have a base of 10. We made them both a common log. Base 10 is called a common log. And everyone's calculator should do that. So you want to round all of these to the 10,000. So that's 10, 100, 1,000, 10,000. That's 4 decimal places. Here you go. So this may be the most important test you've done all year to have a calculator on. Okay? So somebody's gonna be really sad. They won't have a calculator. It's going to happen. I'm ready for it. Who's it gonna be?
Wait, what?
Someone's gonna come Thursday for this test without a calculator. This is probably the most important chapter to have a calculator on. As far as can you figure it out without a calculator? On this test, quite a few problems where you cannot. You know. So please come with a calculator. Just be ready. There might be like somebody stressed in the room. Don't worry about it. Bring yourself a calculator. If you have 2, bring 2. Maybe you can help somebody out on test day. Okay? Somebody bring 2. I have a calculator, but it just like doesn't do what I need it to. So number 2, change of base. I would do log 6 over log 9. If you're not sure how to do this in your calculator, you let me know. I can come by and look at it. Alright, there's numbers 1 and 2. I did not really spend a whole lot of time on that Friday, but I did do 4 and 5. So this is directly from the steps written down in Friday's notes. Oh, 3, 4, and 5. Alright, so I'm thinking 5 to what power is 120? Well, 5 to the third is 125. So this is probably going to be like 2.9 or 2.8. But I'm requiring you to have a perfect exact decimal. 4 decimals in. It's not a guess type problem. So not 2.9. It's 2.8? So we're gonna do we're gonna write the log on both sides. It's the same problem. I just wrote log. And so that was step 1 if you look at Friday's notes. Step 2 is to use the power property and put this guy to the front. So that's A times log 5 equals log 120. And then we'll divide both sides by log 5. And A will equal log base 10, invisible base 10, divided by 120 divided by log base 10 of 5. You gotta show your work. So just 2.9?
Yeah, 2.9 can change.
Quite a bit of change, it sounds like.
Yes.
The change is significant here. We're
Very.
using our calculators to get the change right. Right, this is the exact answer I need. I'm not going to be too flexible about that. Now that we've gone over change of base formula, common logs, your log buttons, and I'm being specific about running to the 10,000th, we need that number exactly. Who's done with number 4? Thumbs up if you're done with number 4. Okay. I'm going to wait a minute and let you guys work ahead. You finished with 5, Matthew? Go ahead and work on number 5 if you're done with number 4. Isn't that working?
Do you try to solve the x's first, or do you divide the logs first? Subtract the x's.
What if we get a negative answer?
Negative answers are okay. Oh, you do the I know it's gonna be really.
Do we round?
Just to the 4th spot. You round this number only. Right log on both sides. Power property. Divide.
Maybe a piece of foundation from the river.
Subtract 3.
From upside down.
So you had to do 1 through 4. I think I did 1 through 4 with you in 19 through 22. Here's 1 through 4. Just check them out. And there's 19 through 22.
Did you show 7 through 12?
I didn't even assign them.
Do you not want me to be
Oh my god, you're literally lying. Why did I do that?
Wait, you didn't send me to? I didn't do that. I do. That's like a really weird way to number to get it sent to them.
There was multiple people who did it.
Literally.
That's why I reached you.
That's so fun because like a lot of us.
How many of you did 7 through 12?
Are we just?
Was that the Albert board and not on the back board?
I did 1 through 4, 19 through 22.
I don't know.
Yeah. 7 through 12.
Put on the board back there.
Oh.
7 through 12.
Why did you
We should get.
There you go. Just 7 through 12.
Wait, where's this? What's a wrong? Please. Please, like 12 cherries. You know what? This is on task. I just don't
No one did 2 through 12.
Yeah, so we're going to have the best you know.
They're like, sorry,
I did do that.
why didn't you like attempt to get out of favor?
And a whole bunch of
Someone's saying if you don't seem to be focused, you don't
You're
have
right about that one too.
and then you lose, or sometimes you're focused and then you're not. Really hurts you. It's really easier just to focus all the time than try to come in and out. That's painful.
I just like zoned out like I gathered. Like I genuinely like told you.
Alright, so I just want to finish this problem right now, explain it. So, with the x plus 1, there's a little more complicated, but what this shows here is expanding. So we separated x log 9 plus 1 times log 9. So we separated this. and then I subtract this over here. And then they have a common x, so I factored an x out. And the last step, which will get you to a calculator, is now dividing log 4 minus log 9.
Why you put the x to the outside?
You don't have to worry about this one. This is for students who worked ahead and tried it. But the problem was that there was x separated. The different thing about number 5 is that there are separate x's. It was difficult to get them together. So we brought them to one side so that the x could be removed as a common factor. So now I have x is approximately log 9 divided by log 4 minus log 9, which your calculator will do. If you want to just skip that one, you have my permission, but I didn't want to leave you hanging if you were trying it.
I was gonna say, I just want to know what the answer was.
Right.
I got 3.818. Or 89. No. I don't remember what the number was after 8. So I don't know if I was wrong.
So the answer is negative 2.095. Alright, we are now going to do word problems in class today. Word problems.
Let's go. What about the
Yeah. Yeah, there's a lot of applications to do.
know what I mean? Suppose you deposit $1,000 in
I
savings.
factored in extra.
Oh, you want me to read it out loud?
Yeah.
Oh, I'm gonna read it by that video.
Yes. I dropped a 2 in this problem, Amanda. Thank you. Suppose you deposit $1,000 in a savings account that pays interest at an annual rate of 5%. No money is added or withdrawn from the account. What is the value of the growth rate? And what equation models the situation? Write your growth equation. These problems are posted in Schoology, so you know it's says 7-6 application of your Bible.
Wait, would I start off with 1,000 like this?
Yes, you
1,000
would.
equals.
No, not equals.
Not equals? How? If they say you deposit 1,000, so don't you have 1,000 in that mix?
So the growth formula that we covered a long time ago, but we reviewed for your quiz. It doesn't matter what I said, we are doing word problems.
Yeah, my brain was just like, I thought she just said we're not going to do word problems today. And then I see a word problem on the board. And I was very confused.
Maybe I did, maybe I didn't. Long story short, we are. So.
Oh, miss. That one always stays on the same. 1 plus
Yep.
6.
Yep.
Yes.
All right, going back to this model, the initial amount goes in the A spot. 1 plus the 0.05. Remember to convert the decimal. And so the equation that models the situation keeps t in for time. But then To answer letter B, for 5 years, we'll use our calculator. And we'll put a 5 in. And for 13, we'll do the same thing. But we'll put a 13 in.
We do the multiplication first and then do the thing, right?
Exponents before multiplication.
So what do we exponent?
I would do 1.05 to the 5th.
Okay.
Correct.
I don't think that's right.
After 5 years, you earned over $276.
No, it is right. It doesn't look right.
And after 13 years, you earned over $885. So, with word problems regarding money, round to cent for money problems. So we've already covered that. That should feel familiar. But this next one we have not done yet, really. How many years will it take for the account to earn $2,500? So I don't know if maybe you want to label this Y here. This Y is like the amount earned over time. So this time we're going to take exactly what we started with in letter A, but we're going to replace Y with 2,500. The question is, how much time will it take to earn $2,500? How'd you figure out 13? No, 13 you only made $1,800. Oh, like it's too much, like it's too long. Yeah, it takes too long. But 13, maybe you got this money when you were 5 and you just left it in the account. You know, 13 years later you didn't do anything and you earned $800. No, because of the exponent there. The correct order of operations would be to divide both sides by 1,000. Which is 2.5. I messed this up. 2.5. Yeah. Okay, so that's 2.5 equals 1.5 to the t. And now what should we do? Jackson, put your phone away. How do we solve this? This is brand new. I have not done this yet. How do I solve this? Yeah, how do we figure out what exponent that is? Log on both sides. Good job. Yeah, these are log word problems. So logarithms solve for exponents. So if you're trying to figure out what the time is, you don't know the exponent, you're going to have to use a logarithm. So just like yesterday, we'll do the power property. Friday. And then divide. You divide log 2.5. You take them together. I'm sorry, log 1.5. I'm trying to get this t by itself, so divide. So in your calculator, this will tell you the time it takes. And this is how people do make financial decisions. This is what software does for us. Helps us make decisions about how long to invest for. Yes, there is. Go ahead and find it.
But I have the TS38
It's there. There's a log button.
Oh, okay. I think I might pass this test.
It will take 19 years to obtain $2,500. That's starting at $1,000 with a 5% interest rate. So with the context of this word problem, how many years will it take for the account to contain this? Different ways that you could have said it is 18.8 years. This is my exact decimal. But if I'm asked about really how many years, at 18 years I don't have it. I won't have it until 19 years. You know?
Less than 3 weeks. $1,000.
Okay, ready for another one?
Yeah.
Hold on, let me see if I can try to do this by myself.
Right, depreciation is a really main theme of accounting. Lots of accountants try to calculate depreciation. You want to depreciate your equipment because you'll owe less taxes on it. So depreciating expensive equipment saves you money. The reason we're subtracting is because this word depreciate actually means go down, decrease. So if something decreases, you put a subtraction sign in it.
Whoa. One of them. Oh, what up, guys? How y'all doing?
Wow, that went down a lot. Let's do that. Jeez. That went down so much I'm questioning it, but that's approximately $500, 25%. So this car after 4 years is only worth $600. And if you had a loan on it, oh, maybe that's why my, oh, I did 2,000. I thought it went down too far. I went ahead and did the subtraction here. So I did 1 minus 0.25. It's in parentheses, so. Sorry, here's the amount. After 4 years, that car's worth $6,000. So for money, you round to the hundredth, and you round exactly as it should. 5 and higher, you round up. Between 0 and 4, you keep it the same. It's 20. I wrote 2, and that messed up my math. It's 20. Now, letter B is more important. It's more difficult. It's more challenging. Honestly, letter A, that's an Algebra 1 curriculum problem. Letter B is the Algebra 2 curriculum problem. What's different? The difference in letter B is it's asking how many years. So you're solving for time. It's when you're solving for time that you have to use a logarithm. $15% a year, that's a nice raise for allowance. You make $3. Every year they're going to give you 15% more. So here's your growth equation. $3 increasing 15% each year. Now, if it's a weekly allowance, $3 a week, that's too much for an elementary age student. They will just buy candy every week. Did you guys get $3 a week in elementary?
I got no allowance.
That's $12 a month. It'd be chips and candy. Yeah. Chips and candy. Chips and candy. So $15 a week, that's definitely too much for elementary. $15 a week for a high school kid, that's $60 a month. That's a gas tank a month. $15 today. Today it is. $60 a month. So it's like 3/4 of a gas tank. Alright, we don't know how many years, but we're hoping to get up to 15. So I'm taking the y out and I'm putting 15 in. I'm replacing the y with 15, not the time. We don't know how long. Now, can you solve this equation? What's our first step, Gabby? Divide by 3. What's the next step, Gabby? Yes, let's skip that step. I love that suggestion. Let's put that T right in front. Matthew, how long is it going to take? Aren't you dying to know? We're talking about years. How many years until your allowance is up to $15 per week, which is good money? This is every problem I think I've done so far. I've put a number in wrong. Okay, just keep going. Log 5 divided by 1.15. It takes 12 years. That's not bad. I mean, if your allowance was 3 when you were 5, and then when you're 17, it's 15. And each year, you just have a little bit more. Now you have gas money. Any questions on using log to solve for time? It's when time is unknown, you have to use log. Let's go on. Last 2 problems and we're done with classwork.
Well, you can't buy tickets anymore, so that kind of sucks.
Two more minutes and we're done. It's not bad. You didn't have to grab it all.
Yours are strange. So if it's 2007 and 2006,
What?
can you just do like a 2 to 10 ratio?
That's gonna be your zero. That's gonna be your.
Don't worry about it.
And then 27 too.
What?
You're right. Alright, so this problem doesn't tell us the growth rate. Yeah, there's no growth rate given here. So we're going to use the data they provided. They said in 2000, and we're going to call that year 0, there was 1,570 alligators. By year 1, there was 1,884 alligators. If the trend continues, how many will there be in 2017? We have done this, and now it's all in words. It looks different. So we're going to pull from our memories this model here, A times B to the X.
Wait, where's the B there?
We don't know B.
Oh, okay.
Yeah. A X squared.
Oh, honestly. What is this trick that you speak of?
So these alligators are increasing 20% a year. That's too much. That's too much.
I'm sure it's your dog. Guess what?
Hold up for tonight. Please study for the test tomorrow.
We don't have one tomorrow.
Thursday. What up, Neve? Why you so quiet, man? You fuck with me no more? Huh? You fuck with me no more? Yeah, come on, you can bro, we got one more class. Yeah, I mean, what was that? Is it Pam? Bro, I was gonna do the same.
Just you and the funniest thing I've seen all day. Here.
So tired of carrying this thing around. I'm like on fire. It's like a little anteater.
I don't know. Yeah. I'll just figure it out. Hopefully she'll realize, and then I can send her your way. Okay. Okay, well, do a little investigative work before I just announce it.
I just wrote it down. We have the RTC, the voice of money. We're doing no, but we're actually doing sequence. Like we're doing, yeah, we're doing the platoon, yeah, and the color guard. We're doing that. Except I'm not gonna be there. I don't know if Clemens is gonna be either because she has to make basic exam that day. Huh? Actually, no, I could do it. I could do it. Oh, they said that they want her to do it. I don't care. Since when did you say here? Okay, wait. I mean, can I do it? I don't want to do it. I don't want to do it.